trying to figure out a new formula for the area of a triangle. And it's a regular triangle. So that means that the triangle is equilateral and equiangular. Okay, so that's an equilateral, equiangular, regular triangle. What is the formula that we already know and love and can use on any triangle that we've been given? Area for a triangle. Who remembers what it is? No, not the Pythagorean theorem. Say it again, Emmanuel? Yeah, so we already know this one. Area equals 1/2 the base times the height. That's the one that we already know. We agree? We know that one already, right? Okay, now, take a look at this triangle. This triangle is a regular triangle. We're trying to find the area. So we don't have which piece of that little equation? Which piece don't we have? We don't have the height, huh? So let's call this. Let's call all these x. This is x, this is x, and this is x, okay? And if it's regular, what is the measure of each of those? We're all ready to go? Okay. So where was I? Yeah, sorry for the interruption. Okay, so each side is x, right? So if the triangle is a regular triangle, what does that mean each angle is? 60. Good. So let's put that in our little triangle here. So we know that this is 60 degrees. We know that's 60 degrees. And we know that is 60 degrees. Everybody on board so far? Okay. All right, so now we can add to our formula over here, right? So we now know the area is going to be 1/2. What's the base in my triangle? X, right? Times the height. The height is the thing that I don't know, right? That's the thing that I don't know. So what I'm going to do is I'm going to create a height. So I'm going to draw an altitude straight down and create a right triangle here. Everybody with me on that part? Okay, good. Now, what is this new angle I have? This is 30 degrees, isn't it? Oh, that's 30 degrees. So what is this distance from here over here? Half of what? Half of the whole thing. So that's x over 2, right? So if this is x over 2, then this over here, divide by 2 and divide this part by 2, right? So, and the height is the thing that I'm looking for. So what is the height now in relationship to the two sides? Yeah, very good. X rad 3 over 2. So now I can replace height with x rad 3 over 2. So my new function looks like this. 1/2 of x times the height, which is x rad 3 over 2. Now we're going to clean that up. Let's simplify that. Let's do the numerators. What's 1 times x? X. What's x times x root 3? What is it? No, what's x times x root 3? X squared root 3. Very good. So I'm going to have x squared root 3 all divided by, what's 2 times 2? 4. Okay. So check it out. We have a brand new formula to find the area of an equilateral triangle. And notice the cool thing about this is we do not need to know the height. All we need to know is a side. Check that out. You don't have to actually know the height anymore to find the area for triangles. All you need to know is the side. As long as your triangle is regular, which means equal sides, equal angles, you can figure that out. Okay. So we're going to put that part onto our toolkit. So box number 2, the second thing, is putting it onto our toolkit. And it looks like this. So we don't need to know the height anymore for finding the area of an equilateral triangle. All we need to know is the length of the side. And we're going to practice that right now. So we're going to go back over here. Let's do the third box. We're going to find the area of this equilateral triangle. So notice I don't know the height. I don't have to know the heights anymore. All I need to know is the length of each side. So according to my theorem, I know that the area of this is going to be x squared times the square root of 3 divided by 4. All I have to know is a side. So that's going to be 3 squared, square root of 3, all divided by 4. How much is 3 squared? 9, right? So this is 9 times the square root of 3, all divided by 4. Now, here's where your calculators come in. Everybody has a different calculator. Okay? So I'm going to show you how to get the answer that you should, and then you'll practice on your own calculator. For example, I'll show you mine. Here's what mine looks like. I'll clear everything out. So I'm going to do the numerator. I'm going to do 3, take the square root, and then multiply it by 9. And that'll give me 15 point whatever. Then I'm going to divide finally by 4. So the answer I'm looking for is about 3.9. So whatever calculator you have right now, please put 3.9 on the screen, and by getting this, by simplifying this expression so that I know you can do it. So whatever calculator you have, please enter 9 square root of 3 divided by 4. You should. Here we go. Let's do another example together. Now in this example, I want to remind you of some algebra that you may have forgotten. When you take the square root of a number and you square it, you just get back the number. Here's an example, right? The square root of 5 squared is equal to 5. Here's another example. The square root of 7 squared is equal to 7 on the left-hand side. So I want you to find the area of this triangle, given that each side is 2 times the square root of 5. So we're going to use the theorem again. Theorem says the area is equal to x squared times the square root of 3, all divided by 4. So area is going to be 2 rad 5, all squared, multiplied by the square root of 3, all divided by 4. Now we have to clean up this top part here. This is the part we have to clean this up. Okay, so 2 square root of 5 all squared. We're going to take 2, square it, and then the square root of 5 unsquare it. You got to square both of them. So what's 2 squared? Yeah, so that's going to be 4 times. What's the square root of 5 squared? 5. So that part is just 4 times 5. You still have a square root of 3 in there, and you still have a 4. Now, since everything's being multiplied, you can cancel out the 4's. Only because you're multiplying. That leaves you with 5 times the square root of 3, which is about, I'll show you what mine is on my calculator. So I'm going to hit 3 square root, multiply it by 5. So you should get 8.7 when we round to 1 decimal place. So 8.7. Please, right now, whatever calculator you're using, please. Here we go. Last 2 ideas. Last 2 ideas here. We're going to figure out how to talk about the central angle of a regular polygon. And the key word here, you guys, is regular. What does regular mean again? Same angle, same side. Okay. So there's a new word. The new word is central angle. I have not yet defined what the central angle is. Let's see if you can figure it out in a couple of pictures I'm going to show you. But to find the central angle for a regular polygon, you just take 360 degrees and you divide it by the number of sides. It's pretty easy. And the reason that works is because it is all regular. And that gives you your measure of a central angle. So I'm going to draw for you what a central angle actually is. No, you don't have to draw it. But try. Yeah, so this is a regular figure. Regular means that all the sides are the same. So my question is, what type of a gon is this? Is it a 5 gon, a 6 gon? Yeah, this is a 12 gon, right? This is a 12 gon. This is a 12 gon, and it's regular. So what is a central angle then? Okay, well, I'm going to find the center. There's the center. And what I'm going to do is I'm going to draw from each vertex to my center. This part right here is a central angle. Yeah. So this is a central angle right here. So if this was the first one, notice that if I did this every single time, that'd be the second one, and then the third one, and then the fourth one, and then the fifth one. So how many of these would I have, guys? 6, 7, 8, 9, 10, 11, and then finally there's 12, right? So how do you find the measure of each one of those angles? Well, since there's, I just take 360 degrees. I'm going to divide it by the number of sides, which is 12. So what would each of those angles have to be? There you go. Each one would have to be 30 degrees, right? So the central angle is a 30-degree central angle. Okay, take a look at this one. How many sides does that thing have? Let's count out together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here's my center. So my central angle is right here. Would this be more or less than my last one? This is a 16 gon, right? How many, or sorry, what is the measure of each central angle? Well, we'll take 360. Divided by 16, what does that give us? 22.5 degrees. So this one is smaller than that one. It definitely looks like it to me, right? So that's my central angle. Take 360 divided by the number of sides. So each one of those has a 22.5 degree measure.